So if I take a look at 36, 36 said that I have n plus 19 is greater than or equal to 10, or, don't forget that's an or, negative 5n plus 3 is greater than 33. Okay, so I'm just going to solve this. I'm going to add a negative 19. So I get n is greater than or equal to a negative 9. I think I did that right. Or, I'm going to add a negative 3. So I get negative 5n is greater than 30. I'm going to divide both sides by negative 5, so n is less than negative 6. So n is greater than negative 9, and n is less than negative 6. So if I graph that, in an OR solution, if you remember, it's the union of both, not the overlap of both. All right, so here's my negative 9. So I have, 9, 8, 7, 6, here's my negative 6, 5, 4, 3, 2, 1, 0. So here's 0. So my n is greater than or equal to negative 9, and n is less than negative 6. If this was an and, it would just be the overlap. Since this is an or, it's any n value that meets one of those or the other. Isn't every single number possible? So L, isn't every single number possible? That's why this is all real numbers. Because every single number would either be greater than or equal to negative 9, or it would be less than or equal to negative 6. All right, what else from the book can I do? Okay. How about the worksheet? Joseph? 2? Okay. Now, I may have made a mistake in my numbers. Let's run through it. If I did, I'll just correct it. All right, so they said the temps that we know are between 10 and 20 degrees Celsius. We want to know the range of temperatures in degrees Fahrenheit. Well, I know degrees Celsius equal to 5/9 times the quantity F minus 32 degrees Fahrenheit, okay? So I know this is our formula. I have a minimum degrees Fahrenheit and Celsius and a maximum degrees Celsius. So our formula for degrees Celsius needs to go in here. What's up? Was it 25? Was that the mistake I made? Okay. So this is going to be 25. Let's correct this as I go. All right, so this is the formula. All right, so my actual degrees Celsius the formula goes in here. So I'm going to put that in there. All right, so let me just make some adjustments here. So this is going to adjust to, thank you, go sit down. This is going to adjust to 45. Thank you for remembering, Alex. If I add those together, this should be 50. And this is going to be 77. And that should be our answer, if I did that math right. So is going to be between, and I did it this way because I said the high and the low, 77 degrees Fahrenheit and 50 degrees Fahrenheit. Joseph, does that help you? Awesome. What else can I do from those three? Yes. Yeah. The worksheet from Friday. Okay, but you can still see it, can't you? Okay, just do it. There's no, whatever. I mean, as long as you didn't like take a marker and scratch it out, you can't see it. It doesn't matter. Just do it. It's number 4 on this from Friday. That's okay. Is there anything else? Okay, put this away. Let's practice some more of these. right. Okay, I'm going to give you this problem I want you to do. Okay, so today is 127. We're going to be practicing compound inequalities. God bless you. All right, so the thing I want you guys to focus on, we talk about story problems. All right, this is a little bit of a review, but I want you guys to really pay attention to this because the problem I'm giving you, you need to remember this. When we do our game plans, we're going to have our minimum, for example, our minimum area is less than or equal to, or it could be less than, whatever that inequality, whether it's less than or less than or equal to. This is the actual area. Let's say area of a triangle. So actual area of a triangle, which is less than or equal to the maximum area of a triangle. What needs to go in here, area of a triangle is 1/2 base times height. So I need to put in here a formula for the area of a triangle. So the reason I'm saying that is that you may have to transform equations. You may have to transform equations because what I'm looking for is a formula. Do not sit near each other. Someone can sit at the very end by L. No, you're good there. Peter, you go over there because I don't want you by Andrew. So the formula that we're putting in, area equals, and the formula for it. Okay, so on that last one we did in class where we had degrees Celsius, if I had given you the maximum and minimum degrees Fahrenheit, you would have to rearrange that equation, okay? So I want you to pay attention to that. I'm going to do that one right now for you, and then I'm going to give you another one to do, okay? So let's say in Michigan, the temperature typically ranges from, I don't know, 65 to 85 degrees Fahrenheit inclusive. That means that those values are included in there. Inclusive means that it includes 65 degrees and it includes 85 degrees. Okay. I want you to find the possible range of temps in degrees Fahrenheit, in degrees Celsius. Well, the formula that I know is Celsius equals 5/9 times a quantity of F minus 32. When we set up our game plan, it's going to be our minimum degrees Fahrenheit is less than or equal to our actual degrees Fahrenheit, which is less than or equal to our maximum degrees Fahrenheit. So in here, I have to have a formula that says degrees Fahrenheit equals. So I need to transform this equation solving for Fahrenheit. Because I need Fahrenheit equals. I want to be, when I'm done, I want to have C is between two values. Can you guys see that? All right, that's the confusing part, is that minimum, maximum, whatever that minimum, maximum value is, that's the formula we're putting in. And the value that you're looking for, that variable that you're looking for, has to be inside your equation. Does that make sense to you guys? So all of you, let's transform this formula, solving for f. So what's the first thing I'm going to do to solve this equation for f? And please don't say use the distributive property. What should I do to start solving this equation for f? Rita? How am I going to do let's get rid of the fraction. So what am I going to do? Yes, I'm going to multiply by 9/5 on both sides. So I end up with 9/5 times c equals f minus 32. Now what? Rafaela? Yep. Now the thing to remember is our degrees Fahrenheit is equal to 9/5 c plus 32. And there's no parentheses there. So here is the formula that we're putting in for our actual degrees Fahrenheit. So I would have 65 is less than or equal to 9/5 times c plus 32, which is less than or equal to 85. And all of you finish that. So the first thing you guys should be doing is adding a negative 32 to both sides. What did I do? What's wrong, Brian? Thank you very much. I'm so happy you're paying attention to what I'm doing. So this should be 18. I think I did that one right. So 53, so that's 165 divided by 9. And I end up with 18? No. So 53 times 5 divided by 9. There we go. This is going to give me 29 degrees Celsius. So I got 18 and 29 as my minimum maximum. How many of you guys got that? All right, and then I would write that as a sentence. Oh, what's up? Well, okay, so that's a good question. When you see temperature on the TV, how do you see it? Yeah, you round it. You're pretending you're not even here. So, Elle, that's what I want you guys thinking is how you leave your answer. When I say to you, like on a test, if you came up to me and asked me that on a test, I would say to you what makes sense. All right, so now instead of me always telling you what to round to, I want you guys making sense of your answer. Okay? If you think it makes sense to round to the nearest tenth on something, because in our life that's how we would see it, then round to the nearest tenth. If you think it's not, if you think it needs to be round to the nearest whole, then round to the nearest whole. I want you guys making sense of what to do, okay? If it was money, obviously we'd have to round to the nearest hundreds. Okay. All right, so are you cool with this idea? All right, so I'm going to give you guys another one. Okay. Okay. So I'm going to show you this picture. This picture goes with it. So we're talking about a spring. All right, watch this. So take a look at this picture, and I'm going to read to you what this says, and then I'll show it to you. The force exerted on a spring is proportional to the distance the spring stretches from its relaxed position. Suppose you stretch a spring D distance in inches, applying a force. So you're pulling on a string, and the force that you're applying is F. For a certain spring, they give us a formula. You apply, so this is what we're, can you guys see the spring while we're pulling it? D is the distance that you're pulling it from at rest position. Are you guys cool with that? Okay, I'm going to show you guys the rest of this, and you guys can figure this out. So here is the rest of that explanation. So are you two supposed to be filling something out, or are you two supposed to be studying something? You're studying as well? Why don't you lay it down? Thank you. Remember, anytime you're using a formula, you need to write down what the variables stand for. So I should see that formula, but I should also see what D represents. I should also see what F represents in your notes, so you are paying attention to what those are. So for us to do this, what do I have to do? For us to do this problem, what do I have to do? Natalie? And what do I have to solve for? Yeah, why do I have to solve for D? I don't have to, I'm not looking to find the actual force. Oh, I'm not looking to, when I'm done, I'm not looking to find the actual force. What do I have the maximum minimum of? I do not have the actual minimum distance. Force. So yeah, I need to solve that for force because what I'm being given are two forces, right? Yeah, okay. So what am I going to do to solve this for force, Natalie? Yep, I'm multiply both of them by F. So I have D is equal to 0.8 times F. Now what, Natalie?
Plug that back into your equation.
No. I cannot plug that back into my equation because the information that I have is my force. Right now, if I plug that back in, the minimum and maximum I would need to plug it back in using this would be the minimum maximum distance. I don't have the minimum maximum distance. I have the minimum maximum force. This is an equation for distance. Distance equals. I need an equation for force. What am I going to do now? I agree totally with what you've done. Now what? Lily? No. You're setting up a compound inequality. I could put the forces in for F and find my minimum and maximum. I'm not saying that's not how you can do it. And then you could just set up an inequality from those two individual solutions. I'm not teaching you how to do that. I'm teaching you how to set up compound inequality problems and solving compound inequality problems. What do I do from here, Ryan? By 0.8. I'm going to divide both sides by 0.8 because I need our equation to say F equals. Because the minimum and the maximum I have are the force measurements. So if my minimum force is less or equal to my actual force, which is less or equal to my maximum force. So I need an equation for force to put in there. I need F equals some equation, and that equation goes in there. Questions so far just on that part? Okay, my next question for you is, should this be equal to, or should this be just less than? Based on what they told us. Should this be equal to, or should it just be less than the minimum and the maximum? Ashley? Exactly. So we say that it's inclusive. Okay, Giselle, your hand had been up. No. Oh, are you good with that? Okay. Elle, are you good so far? Because F is in the denominator. I need F in the numerator. So for me to have F equals, the F has to be in the numerator. Doesn't that make sense to you guys? Right? Because if I just multiply both sides, first of all, I would be dividing both sides by D, not multiplying both sides by D. And I would have 0.8 over D is equal to 1 over F, and that does not help me. I need my F in the numerator. So I have to multiply both sides by F to get it in the numerator on this side, and then I can divide both sides by 0.8, so I get the F alone. So now I'm just going to substitute in my values. So I have 25 is less than or equal to D divided by 0.8, which is less than or equal to 40. If the question here was, these are the minimum maximum forces, what would be my minimum maximum distance? You could simply just substitute 25 into the original equation, get your answer. You could substitute 40 into your equation, get your original answer. You can find your maximum minimum. You can write an inequality statement. But I'm trying to teach you how to set up compound inequality problems and solve them. So I do want you doing that, please. Okay? And all of you solve this. believe I get 20 is less than or equal to D, which is less than or equal to 32, I think. And this would be inches. And I would write that as a sentence. I would write something like the minimum and maximum distance the spring would stretch is 20 and 32 inches, or something like that. And I do expect you to have your capital M in the beginning of your sentence. I expect you to have your dot, your period at the end of the sentence. You guys cool with this? Okay, you guys are good to go?